Okay, so 4-2 trigonometric functions in the unit circle. Last week we talked about radians and degrees. Remember, a radian is the measure of the radius on the circumference of the circle, right? And you had the conversion factors between radians and degrees, and your magic number was pi over 180 and 180 over pi. Correct?
Yeah.
Okay, so that is still going to apply. You're still going to use 1 over 180. Okay, so sine of t. T is an angle. Okay? Typically what the book does, if it's in radians, they put t. If it's in degrees, they put theta. Okay? English letter for radians, Greek for degree, but that doesn't always apply. Okay, that's not a hard and fast rule. I'm just telling you that. Okay, so tangent is y. Okay, but it's really y over r. Okay, in the unit circle, what was r? What was in the unit circle? What was
1?
1. It was 1 unit, yes? Okay, so y over 1 would just be what? Y. But we're going to say y over r because radius is there. It's just 1 in the unit circle. Okay? Cosine of t is x. It is actually x over, guess what? R. I do expect you to add that to it. That's why I wanted you to be done. Okay? Tangent is y over x. And all this is over here is tells you what? Why?
Because you cannot divide by 0.
Because you cannot divide by 0. That's all it is, guys. You shouldn't need somebody to tell you you can't divide by 0. It's just a domain. Okay? Secant is right under sine for a reason. What is the relationship between secant and sine?
Could not tell you what a secant is.
I don't care. Look at your ratios.
Reciprocal.
The reciprocal.
That's the word.
Thank you. Secant and sine are reciprocals of each other. So if you know sine, can you figure out secant?
Yes.
Yes. I never, ever, ever in my life, when somebody said, what is the secant of 30 degrees, I have never rambled off the secant of 30 degrees. The sine of 30 degrees is 1/2, so the secant is 2. Okay? We want to be efficient in what we remember, yes?
Yeah.
As long as I remember sine and secant go together, I can figure out sine, which I'm going to have to do a lot more than I'm ever going to have to do secant. And can't I reciprocate something very quickly and easily?
Yeah.
Yeah. So don't, guys, besides remembering that sine and cosecant, and I said secant and it's cosecant, sorry. Cosecant are reciprocals from each other. That's all you need to know. Okay? Cosine and secant are what of each other? Reciprocals. Okay? Now, a secant line is a line that passes through something twice. That's what a secant line is. You should have learned that in geometry. It's not, we're not going to do much more with that.
Both secants?
Cosecant.
Okay.
Co with the C. I said it like half and half. C is the co. Now, if you look at it, you have sine and cosecant, yes? And you have cosine and secant. So they're paired an S and a C. See that?
Yeah.
If you go cosine cosecant, you're wrong because you have 2 C's. Again, X can't be 0, Y can't be 0. Why can't they be? Because you can't divide by 0. So when it happens and they are 0, the answer is undefined. Okay? So the cosecant at 0, at 1, 0, which would be 0 degrees, yes?
Mm-hmm.
Would be what?
Undefined.
Undefined, because I'm dividing by 0. The secant at 90 degrees, because x would be 0, because it's straight up, right? Would be what? X is 0. Undefined. Okay? So you're going to have an answer. The answer is going to be undefined. Cotangent is the what of tangent?
Reciprocal.
It's a reciprocal. Okay? So everything we do for the next couple days is going to be in a coordinate plane. Everything we do. Okay, find the exact value of the 6 trig functions for the real number t for the given points. So when you do these, I hope you do sine, cosecant, cosine, secant, tangent, cotangent. Why would I do those in that order? Sine, cosecant, cosine, secant. They're reciprocals of each other. Those are known as reciprocal identities. So we have the coordinate -3, 5, and 4, 5. Okay, and we are in the unit circle. So what is R? 1. Okay, so sine, and I do expect you to do it like this. You have to have sine of something, guys. Sine is a function. Functions are an of, right? So you have sine of t equals, what is your ratio that was on your first slide? Y over R. I expect you to write that on every single problem today. Why? Okay, so I have y over r. Well, what is y? 4/5. R is 1. So the answer is 4/5. If it wasn't 1, we'd multiply by the reciprocal there, correct? Yes. So then we're going to go cosecant. And why are we going cosecant next? Reciprocal. And if it was on my own paper, I would do sine and then cosecant right next to it. But I don't think I'll have it. Well, I'll see. If it was my own paper, I'd do it like this. Okay, what is cosecant? What over what? R over y. So I don't have to put it. Oh, yeah, I do. So it's going to be 1 over 4/5, which is going to be what? 1 divided by 4/5. 5/4. Then cosine. Now, when I give you a quiz, I'll mix things all up. Doesn't mean you have to, right? Especially learning them. Okay, cosine is whatever what? So we're going to have -3/5 over 1. So my answer is? Okay, do secant on your own. Or here, we'll do this whole one together. We can do the next one on your own. Okay, secant is what over what? R over x. So 1 over -3/5. So the answer is? -5/3. Tangent of t. Y over x. So then I multiply by the reciprocal, which is 5/3. And the answer is?
That's about 4/3, I guess.
So cotangent is what over what?
X over Y.
X over y.
Would it be a -4/3?
Yes, I did forget my negative. Thank you very much. So it's -3/5 over 4/5. So when I reciprocate that, I get negative, because I usually always pick my negatives first, and that's why I forgot it. Negative what? -3/4. Remember when I reciprocate irrational, like when I reciprocate, if the denominators are the same, it's just going to be numerator or numerator, right? Okay, that is legitimately what it is. So that practice is for you to remember those ratios. So you try the next one on your own. It's not small. No. Questions on these guys? Do we need another one?
No.
Okay. Am I good?
For now.
Let's make your great.
There's a square root. Is that going to make any difference?
No.
No, you got to make sure you don't leave the square root in the denominator, right?
Yeah.
But other than that, there's no difference. This is in what quadrant? What's this one in? What quadrant? The first one.
Which one are you pointing at?
I know. I'm pointing. You can't see where I'm pointing. What quadrant's this one in?
I'd say about
Why do you know it's in the third?
third.
It's negative, negative. What quadrant's this one in?
I'd say about
The first, because they're both positive, right? What quadrant was this one in?
oh,
What quadrant was this one in?
two.
2. Why?
Negative positive.
Negative x, right? What quadrant is this one in? Fourth, because it's a negative y. So when you guys ask me, how do you know what quadrant's that in? I'm going to tell you. Look at the point. Okay? Y is what function? What function should be associated with y?
Sign.
Sine. What function should we associate with x?
Cosine.
Cosine. So wherever y is negative, the sine's going to be negative, correct? Wherever cosine is negative, what's going to be negative?
Cosine.
Where cosine's negative, what's
X.
negative? The x is negative. I switched it around on you. Okay, so I have this. So you might, once in a while, when you look up help, you might see something like this. Oops. Okay. They're the x's and y's, yes?
Oh,
But they're also the sine and cosine.
crazy.
Okay. Now, how do I know if tangent's positive or negative?
Well,
Tangent's x
It's
and
in-
y, right?
it's in 1 or 3.
1 or 3, tangent will be positive because both signs are, the same? Because a positive divided by a positive is a positive. A negative divided by a negative is a positive. And then in 2 and 4, their tangent's going to be negative, isn't it?
Yes.
Okay, it's not something I memorize. If I have to stop and think about it, can I? I just have to think
No
about
time
the
to
x's
stop.
and y's. Brad, please take your hood off.
Looks like a very happy unit in the quadrant.
Okay, your circle. I am going to switch to my camera now because that is going to be awfully small to write on, and that won't be very fun. Okay, you need to do this in pencil because if you make a mistake, you need to be able to erase it. I'm not making you another copy. I told you since day one last year that if I made you a copy, it is something that you should keep forever. Yes.
Yes.
Okay.
Bring him to your funeral.
You're gonna bring him to my funeral? Well.
Miss Vic will never have it.
That's
She's
why I
a
will get rid
vampire.
of it. Say your funeral.
Okay. I will tell you that Mr. Jerkins just told me, and I was surprised. He just told me that when he took a test for when he was doing his degree, he actually could bring in a binder and some notes, and he chose to bring his high school pre-calc binder. And
Damn, they're dirty.
Mrs. Turnus just said last year when she took a stats class, she pulled out her high school stats that she had for me, which was pretty interesting. So actually, I'm going to use this as the top. But I'm going to put the holes on the top because if you leave it in your notebook, then you can look at it. But that's up to you.
Oh, were the holes supposed to be on the bottom?
I just said I'm going to put them on the top.
Well, I know. I was just saying.
Okay, so we are going to build this circle. Okay? We are building it.
Piece by piece?
Piece by piece. Your brain needs to be completely engaged. If you are just copying down things, it's not going to work. Okay? You have to be thinking about what we're doing, giving input, all sorts of fun stuff. Okay, so what degree am I at right here?
0.
0.
300.
So it is 0 degrees. How many radians is that?
0.
0 radians. One line is for degree, one line is for radian.
Why are you writing so close to the
Because we're going to write 2 things on this line. Because it's 2 different things.
360.
Yep, we're not there yet. Okay, so then I move around. What is this?
90.
90 degrees. I come again,
180.
180 degrees. Next one down,
270.
270. And I don't know how to get this off of my screen. The camera thing.
Just hit it. See what happens.
No, that takes a picture.
Hard.
Okay, so then we need to get radians for this. When I go all the way around is how many degrees? 360. Now, I can keep adding, yes?
Yeah.
I can keep adding, keep going rotations, but I'm worried about from 0 to 360 is what I'm worried about. Because after we do that, everything else just keeps repeating. Every coterminal angle has the same exact sine, cosine, tangent, secant, cosecant, cotangent. Okay, do you remember how many radians were in a whole circle?
2. Nope.
2 what?
6.28.
2 pi. Okay, in a full revolution, there are 2 pi radians. So in half of revolution,
There's about pi.
pi, because it's half, right?
Yeah.
Well, what would 90 degrees be then?
Half pi.
So pi over
2.
2. We're doing radians without even using the formula. Every angle on here, you should not be using the formula. So now we got half pieces, yes? So I go 1 pi over 2, 2 pi over 2, which reduces to what?
1
1 pi.
pi.
And then I get what?
3 pi.
3
pi
pi over 2.
I said 2 pi over 3. I ain't gonna mix it up.
Okay.
It's fine.
3 pi over 2, and then I get 4 pi over 2, which is what?
2 pi.
2 pi. It's all about fractions, guys. Everyone understand where I got those radians from?
Yeah.
Okay,
Yes, sir.
so this point right here was 1 unit over, so what is the x?
1, 0.
1 and 0.
Gosh darn it, Evan, you're stop that.
Up, what was your point?
0, 1.
0, 1. Because we're going 1 unit. Again, that unit can be any, right?
Yeah.
Okay. Then I go 1 unit to the left,
Negative 1, 0.
negative 1, 0. And 1 unit down,
0, negative 1.
0, negative 1. So we have that. So we have the quadrantal angles. We now can go through and say, well, cosine would be x, yes? And sine would be y. It would be 1 over 1, which would be what?
1.
1. And sine would be 0 over the radius, which would be 1, so it's still what?
0.
0. Once I know sine and cosine, can I find all the rest of the 6 functions?
Yes.
Yes. Okay. Once I know x and y, I can find, well, r, obviously. You can find all the rest. So, and it goes around. So if I ask you for the cosine of 180 degrees, what would you tell me?
Negative 1, 0.
No, the cosine of
I'd
100,
say about negative 1.
it would be negative 1. It's the x value, correct? What is the sine at 3 pi over 2?
Negative 1.
Negative 1, because it would be sine is what variable? The y. Do you see what I'm doing? What is the cosine at pi over 2? 0. So this is for something for you guys to learn these. It is not a crutch. You will not get this on a test, ever. You will have quizzes over this stuff as we go through it. So again, this is for you to build it. You could build it in your brain every time we do it. That's why I do it in the chunks that I do it in. Okay, so now I'm going to go halfway between 0 and 90. And what angle is this going to be?
45.
45 degrees. So I'm now cutting this top part into 45 chunks, yes?
Yeah.
So it's 1 45 chunk, 2 45 chunk, 3, 4, right? So that means 45 has to go into 180 how many times?
4.
4. So radians is pi over 4. I cut pi into how many chunks? 4. I cut 180 into 4 chunks. 180 is pi. You're going to understand how that is. So if I was doing this, I would have 1 pi over 4, 2 pi over 4, which would be what? Pi over 2, yes. And then I would have what? 3 pi over 4. And then I would have what? 4 pi over 4, which would be pi. And then I go another 45 degree chunk.
5 pi.
It would be 5 pi over 4. And then another one would be 6 pi over 4, which would reduce to what?
3 pi.
3 pi over 2. And then I go another one, I would have what?
7 pi.
Bless you.
Pi over 2.
How about 7 pi over 4?
7 over 4.
This was
You're
6 plus 1 is? What's 6 plus 1?
7.
7. And then
8.
plus another would be 8 pi over 4, which would give you what? 2 pi. Now,
You skipped one.
no, I did not.
Which one did you skip? Borowski.
I have 5 pi, 6 pi, 7 pi. 5 pi over 4, 6 pi over 4, 7 pi over 4.
I messed up then. Somewhere.
Do you have 5 pi over 4 and 7 pi over 4?
Yeah.
Okay, this is 6 pi over 4, which reduces to 3 pi over 4. Okay,
3 pi over 2.
so it is all about this x-axis is actually what we're going to start learning, because one more than pi when they're chunks of 4, right, would be what? 5? Yes? One less than 2 pi when we have 4. If it's 2 pi and we have 4, how many pieces do we have? 8.
Oh, yeah.
4 times 2 is 8. Yes? 1 less than 8 is what? 7. We're going to add up, subtract, like we're going to subtract. So 4 pi over 4 minus 1 is what? 3 pi over 4. Okay, so we're going to be adding up and down from that x-axis. I know in physics you're allowed to draw triangles anywhere you want. Not in here. You can only draw them to the x-axis. Okay, so we need to get the degrees, don't we?
Yes.
So if 3 pi over 4 is a 45 degrees less than 180, I just have to take 180 minus 45, which would give me
135.
135. And 5 pi over 4 was 45 bigger than 180, 225. And 7 pi over 4 was 45 less than 360, 315.
Hey, you didn't?
Okay, so now the next one, we're going to start with the smallest angle there. How many pieces does that cut into? 1, 2, 3, 4, 5, 6.
I was right. I was just talking about something different.
Yeah.
Okay, what goes into 180 6 times? 30? So this is what degrees?
30 degrees.
30 degrees, and the radians is pi over what?
6.
6, because we cut it up into how many pieces?
6.
6. Because 30 goes into 180 how many times? 6. Do you see how I say we're building this?
I understand.
Okay, so then I have 1 more than 0 was pi over 6, yes? And then I'm going to go 1 pi over 6, 2 pi over 6, 3 pi over 6, which gives me what?
Pi over 2.
4 pi over 6, 5 pi over 6.
And then 6 over 6 is just pi.
So 5 pi over 6. And then 6 pi over 6 would be pi. Then I get what? 7 pi over 6.
And then
8 pi over 6. I'm not writing those down. 9 pi over 6, which reduces to what?
3 pi.
3 pi over 2. And then I would have 10 pi over 6. And then I would have what? 11 pi over 6. And then I would have 12 pi over 6, which would be what?
2 pi.
2 pi. Now, when I see a fraction, how a fraction works is the denominator tells you how many pieces you're cutting this up into, yes?
Uh-huh.
So in the second quadrant, do you notice that both of these are 1 less than a whole pi in relation to their denominator?
Yeah.
Do you see that?
Yeah.
Okay, in the third quadrant, how would you say it?
6.
It's 7 pi over 6, 5 pi over 4.
1 more.
It's 1 more than a whole, correct? In the fourth quadrant,
A lot.
it's 1 less than what? I have 11 pi over 6 and 7 pi over 6.
It's 1 less than 2.
It's 1 less than 2 because we have what? 2 pi. Now, I skipped one angle. Yes,
You did.
I did on purpose.
I don't did on purpose.
Yes, I
think you
did.
just Forgot. You
Okay,
didn't see it
so
somewhere.
when I was doing this, I had 1 pi over 2, 1 pi over 6, 2 pi over 6, that reduces to what?
Pi over 3.
Pi over 3. Well, what angle goes into 180 3 times? 60.
Degrees.
So we now have 60-degree chunks.
It would not be Celsius.
Okay? So I have 60-degree pieces. So I'm not going to go around this time. I'm going to go less. So what's 60 degrees less than a whole pi?
120.
Well, it's 120
degrees.
is degrees. But what would the radians be?
2 pi over 3.
2 pi over 3 because 2 is 1 less than what?
3.
3. Okay, well. Oh, we didn't do this one. What's this one going to be, guys, in the third quadrant? It's 1 more than what? What size chunk do we have right here?
45.
No. 30.
210.
So it'd be 210.
Yes.
Okay. Then I have a 60-degree chunk. We need this one in both radians and degrees. So 1 more than a whole pi when we're talking 60, which would be over 3. So 1 more than 3 is what? 4. Brad, please take off your hood and leave it off.
Yeah, B.
And what angle would that be?
Uncle Lard is cold. 240 degrees.
200. How did you get 240?
Uncle
Because I
Lars.
added 30, 210. Or
Oh, well, you should have
conversely,
added-
I subtracted.
Nope. You should.
30.
Nope. You're not gonna. We're 60-degree angle, so we're gonna add 60 to 180. Don't tell me anything about the y-axis.
Alright, Dad.
Okay. What did I say it was all about?
The base?
The x. Okay. So it's a 60-degree chunk, so we add 60 degrees to 180. So I'm going to come over here, and I'm going to subtract 60 because I'm falling. Yes. Subtract 60 from 360.
So
300.
300.
300.
Okay, and I'm 60, so my denominator is 3. So I need to subtract 1 piece from 2 whole when there's 3 in each. So if there's 3 in each and I have 2 whole, how many pieces do I have? 6. So 1 less would be 5. So we got as far as I wanted on notes today.
That's good.
Alright.